Alrighty, let's give this a shot. So this is the AP Physics one-dimensional motion practice sheet. The solutions. So number one, I'll let you read through that. Read through these before you actually look at the rest of them, because I'm going to assume that you have. So what we know, we can see that we know the initial velocity is 20.1 meters per second, and that's going to slow down. So the acceleration, since this is positive and it's slowing down, the acceleration is going to be negative. So negative 4.2 meters per second squared is the acceleration. And it's going to slow down to a final velocity of 11.2 meters per second. And question A asks, how much time does that take? So find t. So we look at all of our equations and see which ones would be the most helpful, and it turns out the one to use is final velocity equals initial velocity plus acceleration times time. And so 11.2 meters per second equals 20.1 meters per second plus negative 4.2 meters per second squared times so many seconds. And if we look at this just from the vantage point of the units, here we have meters over second squared times seconds. This product would give us meters per second. So out of this, we get meters per second. And so we'll have meters per second plus meters per second gives us meters per second. So all of that holds together as it needs to. So that's good. So we would what? Let's see, to solve for t, we would take 11.2 and subtract 20.1, and that's all meters per second, and divide that by negative 4.2 meters per second squared, and that will give us t, and the answer turns out to be 2.1 seconds, rounded to the nearest second. So that's the answer to part A. Part B asks, well, how far does the car travel? So B asks, what's delta x? Well, we now have choices. We can use our newfound answer to part A, hoping it's right, and use delta x equals the initial velocity times time plus 1/2 the acceleration times time squared. And that would, for this, we would use 20.1 meters per second times 2.1 seconds. Notice that gives us meters, plus 1/2 of negative 4.2 meters per second squared, running out of paper, and we multiply that by 2.1 seconds squared. And you'll notice we have seconds squared divided by seconds squared, so that divides out. So we're going to end up with meters, and meters get to give us meters. So if we do it this way, we will get the same answer as if we do it the other way. The other way being, use this equation. Final velocity squared equals initial velocity squared plus 2 times the acceleration times the displacement. And so we plug in 11.2 here, 20.1 here, negative 4.2 there, and we would get delta x. And in both cases, delta x should come out to be 33.2 meters.